Hello there, and welcome to The Sleepy Scientist. Tonight, we drift into a quieter corner of the cosmos, a place where ancient travellers glide through darkness with patient grace. These are comets, the wanderers of our solar system, drifting slowly along paths older than civilization itself. A comet does not hurry. It spends most of its life far from the sun, resting in the deep freeze of space where even starlight grows thin. Out there, everything is still. The only sounds are the soft imagined murmurs of dust settling, ice resting, time itself stretching across quiet distances. Comets sleep for centuries undisturbed, cradled in the darkness beyond the planets. And then, slowly they wake. As a comet moves closer to the sun, the faint warmth stirs its surface. Ice begins to breathe out gas. Dust that has slept for millions of years lifts into space like a sigh. And the comet grows a soft glowing tail, a trail of vapor and sunlight that drifts behind it, stretching for millions of miles. Not burning, not roaring, simply glowing, like a lantern carried through the night. People once believed comets were omens, messages, or wandering spirits, but science has revealed something gentler. Comets are archives of the early solar system, carrying quiet memories of a time when planets were still forming and the sun was young. They are cosmic fossils wrapped in ice. So, tonight settle in. Let the stillness of these ancient wanderers soften your thoughts, and let their slow, drifting journeys guide you toward rest. This is the most relaxing fact about comets to fall asleep to. Far out in the cold reaches of the solar system, a comet begins its long journey in complete silence. It rests in a region where sunlight is only a pale memory, where temperatures fall so low that time seems to freeze along with the ice. This place, the Oort cloud, is like a vast cradle made of darkness, a spherical shell surrounding the solar system, filled with countless icy bodies drifting gently through space. For most of their lives, comets lie here untouched, preserved in the same conditions they formed in billions of years ago. Nothing disturbs them. No storms, no winds, no sound. Just the occasional soft nudge from a passing star or the faint gravitational whisper of the galaxy. A comet may sleep for millions of years in this deep cosmic quiet before beginning the slow, graceful fall toward the sun. When a comet finally begins its inward journey, the motion is incredibly peaceful. There is no sudden burst, no dramatic awakening. The comet simply responds to gravity's soft pull, drifting from the darkness like a leaf set loose on a gentle current. As it approaches the inner solar system, the sunlight grows stronger, warming the comet's surface by tiny degrees, not enough to melt it instantly, but enough to stir it from its ancient stillness. The ice begins to sublimate, solids turning directly into gas, rising like invisible breath from the frozen core. Dust that has been locked inside the comet since the birth of the solar system finally steps into the light, released after an eternity of darkness. The process is slow, delicate, and mesmerizing. The glowing cloud that forms around the comet is called the coma, and it is one of the most calming sights in astronomy. The coma is not a hard shell or a sharp edge. It is a soft sphere of gas and dust surrounding the nucleus like a luminous aura. Sunlight scatters through this cloud, making it glow softly against the darkness of space. The coma expands gently as the comet moves inward, growing larger and more diffuse until it becomes a drifting envelope of light. Unlike planets or moons with defined boundaries, a comet's coma is fluid, always changing, always breathing. It forms a halo that seems more alive than solid, a reminder that even in the cold vacuum of space, gentle processes can create beauty. A comet's tail is often imagined as fire streaking across the sky, but the truth is far more soothing. There is no heat, no burning, no explosion. The tail forms when sunlight pushes the gas and dust in the coma outward, shaping it into long, elegant streams that stretch millions of miles. It's not violence, it's sunlight gently guiding material into space, like wind brushing across sand. The dust tail curves gracefully along the comet's path, while the ion tail points directly away from the sun, glowing faintly blue. Both tails move slowly, drifting in the solar wind like ribbons carried by a soft breeze. They shimmer not with heat, but with reflected sunlight, not a flame but a glow. The nucleus of a comet is surprisingly small compared to the beauty it creates. Hidden beneath the coma, it is just a dark, irregular block of ice, dust and rock, often only a few miles across. Yet this tiny, ancient fragment carries the chemistry of the early solar system within it. When spacecraft have flown near comet nuclei, they've found surfaces that resemble quiet, frozen landscapes. Gentle slopes of dust, patches of jet-black ice, subtle ridges formed by slow sublimation. There is no noise, no motion except the occasional whisper of gas escaping into the coma. The nucleus is the silent heart of the comet, simple, ancient, and enduring. Sometimes, a comet's glow changes from night to night, shifting in brightness and shape. These changes can happen because jets of gas erupt gently from the surface, creating soft plumes that push dust outward in new patterns. The jets are not explosive. They're more like small breaths of vapor escaping through cracks in the ice. These subtle outgassing events create delicate streams of material that spiral around the nucleus, adding texture and movement to the coma. The comet becomes a slow, drifting sculpture shaped by sunlight, guided by gravity, and alive with gentle motion. As the comet approaches its closest point to the Sun, called perihelion, its glow becomes brightest. But even at its peak, the process remains calm. The increased warmth simply encourages more sublimation, creating a larger and more luminous coma. The tail grows longer, the glow spreads wider, and the comet becomes a drifting lantern in the sky. Ancient cultures watched this brightening with awe, seeing comets as messengers or travelers between worlds. Today, we know the brightness is simply sunlight reflecting off ancient ice and dust, nature's quiet reminder of the solar system's earliest days. Once the comet begins its journey away from the Sun, everything slowly reverses. The coma shrinks, the tail shortens, and the comet cools. The outgassing fades until the nucleus becomes quiet again, returning to its deep sleep. The transformation is gentle. The glow dims gradually, fading like embers cooling after a warm fire. Bit by bit, the comet slips back toward the cold outer reaches, leaving behind no sound, no footprints, no trace except the memory of its peaceful passage through the inner solar system. Some comets are known as short-period comets, returning to the Sun on regular orbits. These repeat visitors become familiar friends of astronomy, gentle wanderers who show their glowing faces again and again across generations. With each pass, they shed a little more dust, reshape their surfaces, and reveal new details about their ancient origins. Their slow, cyclical journeys remind us that the cosmos moves in rhythms, not rushes, that even the grand motions of space unfold with patience. Other comets are long-period travelers, taking tens of thousands of years to complete one orbit. When these rare wanderers finally appear in our skies, it is a moment shared not only with the present, but with the ancient past. The last time such a comet passed Earth, humanity may have still been shaping stone tools. The next time it returns, the world will have changed again in unimaginable ways. Yet the comet continues on its timeless path, unchanged in its essence, a symbol of cosmic endurance. Deep within the inner solar system, sunlight glints off the dust that streams from a comet, scattering it into countless tiny particles. Each grain of dust is older than every mountain on Earth, older than every ocean, older even than the continents themselves. These particles drift away slowly, forming a broad path behind the comet known as its dust trail. Over time, this trail spreads gently across the comet's orbit like a soft cosmic fingerprint. Long after the comet has moved on, the dust remains, drifting in silence. When Earth eventually passes through one of these trails, the particles burn gently in our atmosphere, creating meteor showers, streaks of light that spark across the sky for just a moment before fading. These meteor showers are not violent. They are the soft decomposition of a comet's memory, returning gently to the Earth as light. A comet's ion tail is one of the calmest phenomena in the cosmos. While the dust tail curves along the comet's path, the ion tail stretches directly away from the Sun, shaped not by motion but by light itself. When ultraviolet sunlight touches the gases released from the comet, it strips electrons away, turning the gas into glowing plasma. The solar wind, a constant, gentle stream of particles, flowing outward from the Sun, pushes this glowing plasma into a long, straight ribbon. Unlike the dust tail, the ion tail does not drift or bend softly. It points like an arrow of pale blue light, unwavering and serene. It is the most delicate kind of cosmic illumination, sunlight sculpting gas into a silent beam. Sometimes, a comet develops multiple tails, each one glowing with its own texture and purpose. One tail may curve softly like a drifting ribbon, while another stretches straight into the darkness like a beam. Some comets even display faint secondary dust tails that branch gently from the main one, forming subtle forks of light. These faint additional tails appear when particles of different sizes respond differently to sunlight, separating into layers of dust that drift at their own slow tempos. Instead of chaos, these multiple tails create harmony, different streams of material, each following its own quiet path through space. Together, they form a layered, multidimensional glow that feels almost orchestral in its stillness. Up close, the surface of a comet is remarkably dark, darker than coal, darker than fresh asphalt. This blackness might seem surprising for an object that glows so beautifully from afar. But the surface is covered in ancient organic materials, carbon-rich compounds that have survived unchanged since the solar system formed. When sunlight touches this surface, most of it is absorbed rather than reflected. The glow of the comet comes not from its core but from the coma and the tail from dust lifted gently off the surface, catching light like fine powder floating in a sunbeam. The nucleus itself remains quietly hidden beneath this shroud of darkness, storing the frozen chemistry of the early solar system deep within. When spacecraft have approached comets, the images they send back reveal landscapes unlike anything on Earth. The surface is jagged and porous, with cliffs, smooth plains, deep pits, and gentle slopes blanketed in dust. These terrains form slowly over millennia as ice sublimates and dust settles into new shapes. In some images, jets of gas can be seen emerging from shadowed cracks, not eruptions, but gentle exhalations. These jets carry dust into the coma, adding new layers of light with every breath. The surface does not roar or crumble loudly, it simply transforms, weathered by sunlight in the quietest way imaginable. Comets often rotate slowly as they travel, turning with the grace of a drifting leaf. This rotation causes the jets of gas to sweep around the surface, sculpting the coma into a rotating, ever-changing halo. Sometimes the rotation is smooth and predictable, like the slow turning of a music box. Other times it wobbles slightly, creating subtle variations in the glow. This movement brings life to the comet's appearance, giving it personality, not animation in the energetic sense, but a soft, continuous motion that adds calm dynamism to its presence. There are comets that visit the inner solar system frequently, becoming familiar celestial guests. These returning comets carry visible changes each time they appear. New jets, altered shapes, slightly different tails. Each passage carves away a little more ice, reshapes a bit more dust, and reveals deeper layers of their ancient cores. Observing these comets over the centuries is like watching a slow cosmic evolution unfold. Not dramatic, not restless, just gentle aging, the quiet weathering of an object that has circled the sun countless times. Some comets, however, pass through the solar system only once. They fall inward from the Oort cloud, sweep gracefully around the sun, and then drift outward forever, never to return. These one-time visitors are among the purest cosmic wanderers fragments that formed alongside the planets, went untouched for billions of years, and finally emerged into the light for a single, brief encounter with the inner solar system. Their journey is long, their glow brief, and their departure eternal. There is something deeply soothing in the idea of such a journey, a single arc of light, completing its purpose quietly before moving back into the infinity of space. A comet's tail can stretch for millions of miles, yet the material within it is astonishingly thin. If you could gather all the dust and gas from the tail of a comet, compressing it into a solid object, it would fit inside a small suitcase, perhaps even smaller. The breathtaking scale of a comet's tail is not a display of mass, but of delicacy. Sunlight spreading rarefied particles across vast distances. It is a reminder that beauty does not require weight or density. Sometimes it exists in the faintest, softest materials, expanded and illuminated by gentle forces. As a comet retreats from the sun, the tail fades first, dissolving into space like mist vanishing in morning light. The coma shrinks, the jets quiet, and the nucleus becomes dark again. The comet returns to silence, carrying with it the memory of its warm encounter with the inner solar system. It drifts slowly back into the cold, where it will rest for thousands or millions of years. Its journey is cyclical, patient, and serene, a gentle reminder that even the most luminous wonders of the sky spend most of their existence in stillness. As a comet glides toward the sun, its journey takes it through regions of space where the solar wind grows stronger. This wind is a gentle but persistent stream of charged particles that flows outward in all directions. It does not roar or push with force. Instead, it touches the comet like a soft current, subtly shaping the drifting dust and gas around it. The interplay between the solar wind and the comet's outgassing forms delicate structures, and in the tail's subtle waves, gentle twists, and faint ripples that stretch far behind the nucleus. These whispered patterns are visible only through long exposures or careful observation, and they tell a quiet story of the comet's slow dance through the sun's breath. Sometimes a comet's coma becomes so large that it dwarfs the planets themselves. Even though the nucleus is tiny, the cloud of gas around it can expand to hundreds of thousands of miles across. Despite its size, the coma remains ethereal, a diffuse, calming glow that seems more like mist than matter. If you stood inside it, you wouldn't feel anything. The particles are too sparse, too delicate. Light passes through with ease, scattering in soft gradients that change with every slight shift in the comet's rotation. This immense glowing envelope is a gentle reminder that size does not always equate to heaviness. Some of the largest structures in nature are also the lightest. When comets pass close to the sun, they sometimes brighten rapidly in an event known as an outburst. This brightening is not explosive in the dramatic sense. Rather, it is the comet releasing a sudden, peaceful breath of gas and dust as new pockets of ice are warmed. The coma expands, the tail grows more luminous, and the comet takes on a glow that feels almost alive. These outbursts are unpredictable and fleeting, lasting hours or days before fading back to a calmer state. They are the sky's quiet surprises moments, when a sleeping traveller sighs and reveals a little more of its hidden beauty. There are comets whose orbits tilt steeply, taking them far above and below the plane, where the planets circle. These tilted paths give them a unique perspective of the solar system, allowing them to sweep gracefully through regions where almost nothing else travels. From this elevated vantage, a comet arcs through space like a solitary dancer moving along a private stage. When it finally crosses the plane of the planets, its tail may stretch in unusual angles, casting light in directions that feel unexpected and serene. These inclined orbits add a touch of individuality to each comet's journey. No two paths are ever quite the same. Some comets survive countless visits to the inner solar system, gradually shedding their outer layers until they become something new. Over time, repeated journeys near the sun deplete their ice, leaving behind darker, rockier cores. These spent comets may eventually lose their tails entirely, transforming into quiet, inert objects that resemble asteroids. Yet their past lives linger in their composition, ancient dust sealed inside, a memory of the times they once glowed across the sky. These faded comets embody a gentle cosmic aging process, changing slowly and peacefully as the millennia pass. A comet's nucleus is a patchwork of textures. Some regions are smooth plains of fine dust, worn down by cycles of gentle warming and cooling. Other areas contain steep cliffs that rise sharply from the surface, carved by the slow retreat of ice. There are also pits, deep circular depressions, that form when pockets of volatile material sublimate and leave behind quiet hollows. The entire nucleus is shaped not by violent collisions or tectonic forces, but by sunlight and time. Every feature, every ridge and slope is the result of patient, natural sculpting. To observe such a landscape is to witness the quiet persistence of nature on the smallest scales. Occasionally, a comet fragments into several pieces during its journey. This fragmentation might sound dramatic, but in most cases it is gentle like a loaf of bread crumbling softly. When stresses build inside the nucleus, or when sunlight warms the ice unevenly, the comet may split into drifting fragments that continue their orbit together. These fragments glow softly, each surrounded by its own small coma. The resulting scene is like a family of glowing travelers moving through the sky in silent companionship. Their motion is slow, harmonious, and deeply peaceful. When a comet nears Earth, even if it passes millions of miles away, its tail can stretch across a significant portion of our night sky. The tail's sheer size creates a peaceful illusion of proximity, as though the comet is brushing the world with gentle light. Ancient observers described these moments with awe, seeing the sky transformed by long, fluid strokes of brightness. Even today, such comets inspire a quiet sense of wonder. Their tails act like celestial paintbrushes, filling the night with soft colour and giving Earth a brief, serene connection to the outer solar system. Some comets become famous for their beauty, returning often enough that entire generations witness them. Halley's Comet is one example, appearing roughly every 76 years, weaving through history as a recurring visitor. When it appears, it offers a sense of continuity, connecting the present to the distant past in a way that feels gentle and grounding. The comet that ancient astronomers watched is the same one we see today, unchanged in its essence, passing through the centuries with quiet loyalty. Comets have also played a subtle role in shaping planets, including Earth. In the early days of the solar system, they carried water ice and organic molecules to young worlds, delivering the ingredients that could someday support life. They did not crash with violence in most cases. Many simply drifted close enough for their dust to mingle with forming atmospheres. Their contributions were gentle, dissolved over time into the fabric of planets. They were among the universe's first messengers of possibility, quiet carriers of life's earliest materials. As a comet glides farther from the sun after its closest approach, the warmth that once stirred it slowly fades. The gases that once lifted into space begin to settle. The jets quiet and the beautiful tails shrink in length until they dissolve entirely. This transition from glowing wanderer to silent traveller is not abrupt. It happens gently, like a breath slowing down after exertion. The comet grows dimmer each passing day, returning to the deep calm of outer space. It slips quietly into the shadows, carrying faint traces of its brief luminous display. The recession is peaceful, a reminder that even the brightest brilliance eventually settles into rest. Sometimes, comets travel in pairs or groups, not because they form together, but because one comet fragmented long ago, creating several smaller companions. These related fragments follow nearly identical paths around the Sun, drifting through space like members of a quiet family. Over centuries, they may separate by millions of miles, yet their orbits remain linked, whispering of a shared origin. When they pass the Sun, each fragment glows with its own faint halo, creating a multi-point display of coordinated light. Such groupings fill poetic individual wanderers connected by a memory carved from ice and time. The dust released by comets often forms beautiful streams in the solar system, and these streams can persist for ages. They linger in space long after the comet has moved on, following its orbital path like a soft, glowing trail. When Earth crosses one of these ancient pathways, the dust drifts into our atmosphere, meeting the air at high speeds. Instead of falling as particles, they turn into light, brief streaks that shimmer and disappear. Meteor showers are not explosions, they're gentle farewells from comets, the final soft glow of dust completing its journey. Each streak is a moment of quiet connection between Earth and a wandering body millions of miles away. Some comets spend so much time far from the Sun that their surfaces become layered in fragile, powdery frost. This frost can be incredibly thin, mere micrometers, yet it blankets the nucleus in a soft coat that glistens faintly when touched by light. As the comet warms during its journey inward, the frost sublimates delicately, carrying tiny grains of ancient dust along with it. These grains drift into the coma, swirling around the nucleus like particles suspended in a gentle snow globe. The atmosphere around the comet becomes a cloud of memory, rising softly into space. When a comet approaches the inner solar system after thousands of years, it crosses paths with planets that have long since formed, evolved, and changed. The planets shine brightly in the sky. It passes through Venus, glowing like a lantern, Jupiter massive and steady, Saturn ringed like a distant crown. The comet drifts past them in silence, observing their brilliance in its own quiet way. These encounters are peaceful alignments, moments when old wanderers and established worlds share the same gentle stage. Though separated by great distances, the harmony of their orbits creates a cosmic choreography that unfolds without sound. Comets that pass close to the Sun can develop long, flowing dust tails shaped not just by sunlight, but by subtle variations in particle size. Larger grains fall behind slowly, staying near the nucleus, while smaller grains drift farther, sculpting the curved arc of the tail. The separation is delicate, each grain finding its own path based on how it responds to light. Over millions of miles, these slight differences create elegant gradients of brightness. The tail becomes a layered tapestry of particles drifting at different tempos, moving together in deep cosmic silence. Occasionally, comets carry frozen gases that produce unusual colours when illuminated. Carbon monoxide can create faint blues. Sodium vapour can produce soft yellow glows. Though rare, these colours add a gentle vibrancy to the comet's appearance, blending subtly with the classic white and pale green tones of sublimating ice. The colours do not appear sharply. They blend like watercolour washes, spreading softly across the coma. Observers who witness these hues describe them as dreamlike, delicate, and strangely emotional, as if the comet were expressing mood through the language of light. Comets carry organic molecules that date back to the formation of the solar system, including compounds that may have existed before Earth itself formed. These molecules, simple but meaningful, lie locked in the icy matrix of the nucleus. When the ice sublimates, they rise into the coma, drifting through space for the first time in billions of years. These ancient molecules float gently, illuminated by starlight, releasing the oldest chemistry known to us. Scientists who study these materials often describe a deep sense of reverence. To examine comet dust is to touch the earliest chapter of the solar system, preserved in silence. The paths comets follow are shaped by gravity, a gentle sculptor working through cosmic time. Every planet, every moon, every minor body in the solar system exerts a small pull on a passing comet, subtly adjusting its trajectory. Over thousands of years, these countless faint tugs reshape the orbit, turning it into the elegant arcs we see today. The comet is never forced violently. Instead, it drifts along a path shaped by soft influences layered over eons. Its journey becomes a story written in gentle gravitational whispers. When comets pass near the giant planets, their orbits can change dramatically. A close, peaceful encounter with Jupiter, for instance, might curve the comet's path, shorten its period, or send it drifting toward the far reaches of space. Jupiter's influence is immense, yet the interaction is quiet, a gravitational conversation, rather than a collision. The comet responds with a subtle shift, adjusting its long-term route through the solar system. These moments remind us that even in the vastness of the cosmos, relationships shape journeys. The comet moves on, forever altered by the encounter, yet unchanged in its essential calmness. When comets drift through the inner solar system, sunlight streams through their dust like light filtering through mist. Each grain becomes a tiny mirror scattering sunlight in all directions. To the naked eye, it may look like a soft glow, but up close the effect is incredibly intricate. Dust particles spin slowly, catching light at different angles, creating shifting patterns of brightness that ripple through the coma. These ripples are gentle and constant, like tiny waves in a pond stirred by the faintest breeze. The entire glow of the comet becomes a quiet symphony of reflections, each particle playing its own soft note. As comets circle the sun, their tails sometimes sweep through regions where charged particles from solar storms are more intense. These interactions can create delicate, wave-like disturbances in the tail, known as tail disconnections. Despite the dramatic name, the event is incredibly serene. A thin segment of the iron tail simply drifts away, carried along by solar winds, while a new section forms seamlessly behind the nucleus. It's a gentle shedding, like a trail of mist being brushed away by invisible hands. The comet continues on its journey, untroubled and steady, its tail reforming quietly in its wake. There are comets whose surfaces produce tiny jets that mimic the rotation of miniature geysers. These jets appear where sunlight warms pockets of ice just beneath the surface. The vapor escapes in graceful plumes, carrying fine dust upward in slow, curling arcs. Over time, these plumes carve delicate features into the comet's surface: smooth fans, subtle ridges, faint depressions. The jets are not loud or forceful, they are the soft exhalations of a body warmed by starlight. Each plume rises like a slow breath, expanding into the coma and merging with the surrounding glow. Some comets rotate irregularly, turning in ways that are both unpredictable and beautifully complex. Their spin rates may speed up or slow down as sunlight warms one side more than the other, creating subtle shifts in momentum. These small changes are enough to alter the comet's orientation in gentle, drifting motions. Observers watching from spacecraft see the surface turning like a slow, drifting dance, sometimes wobbling, sometimes gliding smoothly, always in a rhythm shaped by light and temperature. This irregular rotation gives comets a sense of personality, as though each one moves through space with its own quiet intentions. When comets are at their farthest point from the Sun, they enter a state of near-total stillness known as aphelion. In this remote silence, the comet is surrounded by darkness so deep that even starlight feels faint. Temperatures drop to unimaginable lows, freezing gases solid and sealing the nucleus in a deep, ancient sleep. No tail forms here, no coma glows, no jets stir. The comet becomes a quiet relic floating through the outer reaches, unchanging, unnoticed, and perfectly at rest. This dormancy can last for centuries or millennia, a peaceful hibernation that preserves the comet until gravity calls it inward again. Occasionally, comets pass close enough to Earth that they become visible even without using telescopes. These bright visitors illuminate the sky with gentle arcs of colour, appearing just before dawn or just after sunset. Their glow feels almost otherworldly, not sharp like stars, not diffused like clouds, but something in between. People across continents pause in their routines to watch these silent travellers. The comet becomes a shared moment of calm across the world. Strangers looking up at the same gentle streak of light, feeling the same quiet wonder. A comet's orbit can stretch so wide that it carries the nucleus into regions where gravity from nearby stars begins to compete with the Sun's pull. In these outer zones, the comet feels the influence of neighbouring systems. These faint gravitational nudges may tilt its orbit slightly, alter its path, or give it a soft push that sends it drifting inward once more. These interactions are subtle, so subtle that they unfold over millions of years, yet they shape the comet's destiny, guiding its return to the inner solar system where it will once again glow. The dust grains released by comets often contain tiny voids. Microscopic cavities formed when mixtures of ice and rock froze together in the early solar system. When sunlight strikes these grains, the light bounces within them in complex ways, scattering softly and creating an even more diffuse glow. This scattering effect gives comet tails their gentle milky appearance, enhancing the softness of the light. It's not a bright, harsh reflection, but a mellow diffusion like moonlight filtered through thin clouds. This diffused light softens the entire comet, giving it a dreamy presence against the night sky. Some comets carry ancient ice that predates our Sun. These ices formed in the cold interstellar cloud that existed before the solar system took shape. When these comets warm near the Sun and release their vapours, they're essentially breathing out remnants of a time before planets, moons, and life. This ancient ice turns into light, glowing softly as it sublimates into space. In witnessing the glow of a comet, we are seeing the radiance of material older than Earth itself, light created from the very origins of our cosmic home. As a comet moves away from the inner solar system, its final traces of light fade slowly, returning it to the darkness. The tail dissolves into the solar wind, the coma shrinks into invisibility, and the nucleus darkens. Yet nothing about this disappearance feels abrupt. It is a gentle withdrawal, as if the comet knows how to step softly back into obscurity. It carries with it the memory of sunlight, the warmth of brief brightness, and the path it traced through space. And then it returns to silence, a silent traveller waiting patiently for its next cycle of awakening. There are comets whose orbits carry them close to the Sun, close enough that the heat transforms their surfaces in subtle, graceful ways. As they approach, the sunlight penetrates the topmost layers of ice, awakening trapped pockets of gas that have rested in darkness for billions of years. These pockets release their contents slowly, sending out thin, curling plumes that rise from the nucleus like soft ribbons of vapour. The warming is never sudden. It spreads gradually across the surface, creating a mosaic of brightness and shadow as the comet turns. At this stage, the comet feels almost alive, as if it is breathing in light and exhaling dust into the silent expanse of space. Though comets look fragile, their cores contain some of the strongest natural bonds in the universe. chemical structures formed under extreme cold and preserved without disturbance for immense stretches of time. These bonds are not rigid or brittle, they're flexible in the subtle way that icy mixtures can be. They allow comets to survive their long journeys, resisting fracture even as they warm. Only gentle sublimation alters their surfaces. This quiet resilience is a signature of ancient matter. It reflects an endurance that does not shout but persists calmly across eons. Many comets contain grains of crystalline ice that formed close to the young sun before being carried outward to frigid regions. This means that some of the material inside a comet experienced warmth long before being preserved in the cold depths of space. This journey, from heat to cold and back again, created textures within the nucleus that respond softly when sunlight returns. Crystalline ice sublimates in smoother patterns, releasing gas in even fluid streams. These streams help shape the coma into a gentle symmetrical halo, giving the comet a balanced and peaceful appearance as it glows. Comets often carry magnetic signatures locked within their particles, quiet imprints of the environments they passed through long ago. These magnetic traces are subtle, so faint they cannot be detected from afar, but up close, they whisper stories of early solar winds, ancient stellar influences, and formative cosmic conditions. The dust within a comet behaves like a time capsule not just of matter but of energy. When these grains drift into the coma, they carry with them quiet echo of magnetic histories, adding depth to the comet's silent narrative. Some comets have been captured by giant planets in the past, temporarily becoming part of a planet's gravitational family before being released again. These cosmic detours do not disturb the comet's essential nature. They simply bend its path gently for a time. The comet continues drifting, adjusting to the new curve of its orbit without resistance. Over millennia, these gravitational encounters create elegant, looping paths that resemble strokes of calligraphy across the solar system. The comet's journey becomes a work of art written in gravity and time, unfolding slowly in the dark. When comets originate from the Kuiper belt rather than the Oort cloud, their stories are different but equally serene. These comets begin life among icy worlds and dwarf planets beyond Neptune, in a region filled with quiet drifting bodies. They travel more frequently through the inner solar system but move with the same unhurried grace. Their ices contain layers formed over billions of years, slow accumulations of frost, dust, and frozen gases. Each layer tells a story of seasons that lasted centuries, of cycles shaped by sunlight so faint it barely touched their surfaces. These comets carry the patient rhythm of distant neighborhoods in space. Some comets glow brightly even before forming noticeable tails, their comas expanding quickly as they warm. This early brightening creates an illusion of solidity, as if the comet is larger than it truly is, but the brightness is simply scattered sunlight, reflected by millions of tiny ice crystals suspended in vapor. The glow builds gradually, spreading outward in soft layers that look like the blooming of a luminous flower. Observers often describe these early comas as peaceful, warm, and oddly comforting, an almost gentle presence in the cold night sky. On rare occasions, comets pass close enough to Earth that their tails appear to stretch dramatically across the night, filling the sky with fluid arcs of brightness. The sight is serene and overwhelming in equal measure. The tail does not glow with intense force. It shimmers softly, illuminated by sunlight that has traveled millions of miles. The arc across the sky can look like a bridge of light, connecting distant horizons. Ancient civilizations watched these displays with reverence, feeling the sky open in a way that dissolved boundaries between Earth and the cosmos. There are comets whose orbits align with Earth's perspective just right, creating the illusion of a stationary glow in the sky. Though the comet moves quickly through space, its path aligns so perfectly with our view that it appears almost motionless. Night after night, it remains in nearly the same position, glowing faintly like a star with a soft trailing brushstroke of light. This stillness adds to the sense of calm the comet radiates, as if it is holding its place in the sky just long enough for Earth to notice. When comets fade from sight, their light does not disappear abruptly. It softens gradually, blending back into the background of stars. The coma shrinks, the tail dissolves, and the nucleus hides once again in shadow. This fading mirrors the gentle rhythm of falling asleep, brightness giving way to quiet, motion giving way to rest. The comet returns to darkness with dignity, preserving the memory of its glow until gravity calls it back for another cycle of light. As a comet travels through space, it carries within it a profound temperature contrast. The surface facing the sun warms slightly, enough to release gentle streams of vapor, while the opposite side remains locked in ancient cold. This difference creates a slow, even migration of heat across the nucleus. Instead of violent cracking or melting, the comet adapts quietly, adjusting its thermal rhythm with patience. The warmth seeps inward only a few centimeters, never disturbing the deep, frozen heart. This delicate balance between warmth and cold defines the comet's entire existence, a slow breathing pattern written in ice. The dust that escapes from a comet contains microscopic minerals formed in distant regions of the early solar system, perhaps even in other stars long gone. These tiny particles drift into space like floating memories. Scientists studying comet dust have found materials that originated in fiery stellar environments, carried across the galaxy before becoming part of the young solar system. This means a comet is not merely a relic of our sun's formation, it is a traveller that holds fragments of other worlds, other suns and cosmic eras long before Earth existed. Each grain drifting from the coma is a quiet messenger from deep time. When a comet approaches the sun, its tail always points away from the sunlight, no matter which direction the comet is moving. This creates the peaceful illusion that the tail is guiding the journey, stretching ahead when the comet recedes and trailing behind as it approaches. The alignment happens because of the solar wind's constant influence, shaping the tail like a flowing ribbon. This perfect orientation gives comets a serene sense of direction, as if they travel with an invisible compass that always points outward toward the cold regions of space. Some comets contain frozen carbon dioxide dry ice which sublimates at much lower temperatures than water ice. This allows a comet to begin glowing softly even in distant regions where sunlight is weak. These early signs of activity are subtle but beautiful, faint wisps drifting away from the nucleus, soft halos forming slowly, and dust rising into space long before the comet becomes fully illuminated. These early breaths of vapor remind us that a comet is sensitive, responding gently to even the lightest touch of warmth. As comets wander closer to the sun, they sometimes develop a tail within a tail, a soft, narrow streak of dust nested inside a broader halo. This inner tail forms when heavier particles fall behind more slowly, remaining closer to the nucleus while lighter grains drift farther outward. The effect is peaceful and symmetrical, a thin, delicate line glowing at the center of a wider, more diffuse arc. It is a structure created not by strength, but by differences so subtle they seem almost imaginary, yet together they form a tranquil layered beauty unique to comets. The coma of a comet can sometimes grow so large and diffuse that it encloses the entire nucleus like a floating cloud. Within this cloud, tiny dust grains drift in slow, circular motions. These motions are influenced by a combination of the comet's rotation and gentle outward pressure from sunlight. The dust does not swirl quickly, it moves in slow spirals, like motes drifting in a sunbeam. Viewed up close, the coma would appear tranquil and hazy, a suspended cloud where each particle moves freely without colliding or rushing. It is a realm of perfect stillness and slow drifting motion intertwined. Some comets produce faint, ghost-like halos far beyond the main coma pale, extended glows that surround the primary cloud. These halos form when the smallest particles, lighter than smoke, drift far from the nucleus before sunlight scatters across them. To the eye, these halos are barely visible, like soft veils wrapped around the brighter core. They give the comet an ethereal appearance, as though surrounded by layers of quiet light. These extended glows remind us that even the smallest particles contribute to the comet's beauty, adding softness to its presence. During certain passages near the sun, a comet's tail may appear braided, forming delicate intertwining threads. These braids happen when different streams of dust emerge from rotating jets on the nucleus, weaving together in space. The braiding is subtle thin strands spiraling gently around each other, illuminated by sunlight. It looks like cosmic embroidery, crafted stitch by forces too gentle to feel. This delicate structure drifts behind the comet for millions of miles, a soft testament to the harmony between rotation, sunlight, and dust. Comets sometimes leave behind faint clouds of debris called dust shells. These shells form when a comet releases bursts of material in rhythmic intervals, perhaps tied to its rotation or internal pockets of warmth. Each burst expands outward in a spherical sheet, eventually becoming part of a series of layered shells. These shells drift through space like the rings of a tree, marking moments of activity that occurred quietly and naturally. Long after the main comet has moved away, the shells remain, floating gently along its orbital path, each one a soft echo of ancient breaths. When a comet travels near the planets, gravitational forces can create gentle rhythms in its orbit. These interactions can cause the comet to fall into resonances, repeating patterns where its path aligns harmoniously with the planet's motion. These resonances are peaceful and predictable, drawing the comet into synchrony with the celestial body. Over time, the comet may complete a cycle that perfectly matches several rotations of a planet, like dancers moving in coordinated circles across a vast silent floor. These gravitational harmonies are among the quietest interactions in the solar system, shaping orbit through rhythm rather than force. There are moments when a comet moves through a region of space where dust from previous orbits still lingers. As the comet glides through this familiar pathway, it quietly gathers some of the particles it once released. These grains settle back onto its surface or drift gently into the coma, creating a subtle cycle of return. It's as if the comet is revisiting fragments of its own past, touching memories that have floated in space for centuries. This gentle reunification creates a sense of continuity, a soft reminder that even in the vastness of the cosmos, paths cross and stories fold back into themselves. Some comets contain tiny crystalline forms of silicate minerals, shaped in the early solar system under higher temperatures, before being transported outward into colder regions. These crystals now sleep within the nucleus, locked in ice. When they sublimate and drift into the coma, they scatter warm, delicate wavelengths of sunlight that give the comet a faintly golden tint under certain conditions. The glow is never intense, it's a muted warmth, like candlelight behind frosted glass. These minerals carry the memory of early solar heat, glowing softly as they are released for the first time in billions of years. When a comet interacts with the magnetic field of the solar wind, it can produce subtle structures within its ion tail, faint folds, waves, and shifting textures that ripple silently through the plasma. These ripples move slowly, shaped by invisible currents that flow from the sun. To the eye, they appear as gentle variations in brightness, drifting like shadows across a curtain of light. The tail becomes a living tapestry, responding softly to forces that lie far beyond human senses. These patterns remind us that the cosmos is full of motion too delicate to perceive directly, yet beautiful when illuminated. A comet's journey through space is influenced not only by gravity but by faint continual pressure from sunlight itself. This pressure, though incredibly weak, nudges dust grains in specific directions, pushing lighter particles farther and allowing heavier ones to remain closer to the nucleus. The result is a slow, natural sorting process, a serene choreography guided by light. Over time, sunlight shapes the tail into layered arcs, each one composed of particles with their own physical story. The tail becomes a record of how light gently rearranges matter across millions of miles. As a comet ages, it undergoes subtle changes in its internal structure. Cavities may form as pockets of volatile ice sublimate, creating voids that shift slowly under the comet's own gravity. These internal changes happen silently, without cracking or collapse. Over centuries, the voids adjust, redistributing weight inside the nucleus. This internal evolution is not violent but patient, like a frozen body slowly stretching and settling into a more comfortable shape. These changes contribute to variations in outgassing patterns, shaping how the comet glows each time it approaches the sun. Some comets move through regions where interplanetary dust is denser, causing their comas to gather additional particles that did not originate from within the nucleus. These foreign grains join the comet's own material, blending into a luminous cloud that travels with it through space. This subtle interaction means that comets are not isolated travelers, they exchange material with the solar system in quiet, unnoticed ways. Their glow becomes a blend of their own ancient dust and whispers from the cosmic environment they pass through, creating a soft record of everywhere they've been. A comet's appearance can change depending on the angle at which sunlight strikes its dust and gas. When viewed from behind, the tail may appear brighter and longer, reflecting sunlight forward like a veil illuminated from the back. From the side, layered gradients become visible soft transitions, from bright center to diffused edges. When seen head-on, the coma may glow like a round, delicate lantern floating in space. Each perspective reveals a new facet of the comet's gentle beauty, proving that even a single object can hold countless ways to be seen quietly and peacefully. Sometimes, a comet's dust contains rare organic compounds that fluoresce under ultraviolet light. These compounds release a faint glow when excited by sunlight, adding subtle shades to the coma. The glow is extremely gentle, not enough to shine brightly, but enough to add a dreamy softness to the comet's appearance. This faint fluorescence is unique, a whisper from molecules that have remained unchanged since the dawn of the solar system. When they finally encounter sunlight, they reveal their presence through the softest radiance imaginable. The rotation of a comet often creates faint spirals in the flow of dust leaving its surface. These spirals emerge when jets of vapor released from different regions align with the spin of the nucleus, wrapping the dust into curved, graceful shapes. The resulting structures are barely visible, like delicate fingerprints imprinted into the coma. They drift outwards, slowly unraveling over millions of miles. These gentle spirals give the comet a quiet sense of motion, even when observed from far away, as if the nucleus is weaving soft patterns into the space around it. Even after a comet finishes its journey near the Sun, the effects of its passage continue to echo for years. Dust and gas left behind fill the comet's orbital trail, creating regions of space that glimmer faintly when touched by sunlight. These trails become the sources of meteor showers, drifting steadily across Earth's path. The comet may be far away, asleep in the darkness once more, but the remnants of its activity continue to create gentle light in Earth's sky, small, brief streaks that last only a heartbeat, but carry centuries of cosmic history. It's a reminder that even the quietest wanderers leave behind beauty long after they have passed. There are moments when a comet moves through a region of space where dust from previous orbits still lingers. As the comet glides through this familiar pathway, it quietly gathers some of the particles it once released. These grains settle back onto its surface or drift gently into the coma, creating a subtle cycle of return. It's as if the comet is revisiting fragments of its own past, touching memories that have floated in space for centuries. This gentle reunification creates a sense of continuity, a soft reminder that even in the vastness of the cosmos, paths cross and stories fold back into themselves. Some comets contain tiny crystalline forms of silicate minerals, shaped in the early solar system under higher temperatures before being transported outward into colder regions. These crystals now sleep within the nucleus, locked in ice. When they sublimate and drift into the coma, they scatter warm, delicate wavelengths of sunlight that give the comet a faintly golden tint under certain conditions. The glow is never intense. It's a muted warmth, like candlelight behind frosted glass. These minerals carry the memory of early solar heat, glowing softly as they are released for the first time in billions of years. When a comet interacts with the magnetic field of the solar wind, it can produce subtle structures within its ion tail, faint folds, waves, and shifting textures that ripple silently through the plasma. These ripples move slowly, shaped by invisible currents that flow from the sun. To the eye, they appear as gentle variations in brightness, drifting like shadows across a curtain of light. The tail becomes a living tapestry, responding softly to forces that lie far beyond human senses. These patterns remind us that the cosmos is full of motion too delicate to perceive directly, yet beautiful when illuminated. A comet's journey through space is influenced not only by gravity, but by faint, continual pressure from sunlight itself. This pressure, though incredibly weak, nudges dust grains in specific directions, pushing lighter particles farther and allowing heavier ones to remain closer to the nucleus. The result is a slow, natural sorting process, a serene choreography guided by light. Over time, sunlight shapes the tail into layered arcs, each one composed of particles with their own physical story. The tail becomes a record of how light gently rearranges matter across millions of miles. As a comet ages, it undergoes subtle changes in its internal structure. Cavities may form as pockets of volatile ice sublimate, creating voids that shift slowly under the comet's own gravity. These internal changes happen silently, without cracking or collapse. Over centuries, the voids adjust, redistributing weight inside the nucleus. This internal evolution is not violent but patient, like a frozen body slowly stretching and settling into a more comfortable shape. These changes contribute to variations in outgassing patterns, shaping how the comet glows each time it approaches the Sun. Some comets move through regions where interplanetary dust is denser, causing their comas to gather additional particles that did not originate from within the nucleus. These foreign grains join the comet's own material, blending into a luminous cloud that travels with it through space. This subtle interaction means that comets are not isolated travelers, they exchange material with the solar system in quiet, unnoticed ways. Their glow becomes a blend of their own ancient dust and whispers from the cosmic environment they pass through, creating a soft record of everywhere they've been. A comet's appearance can change depending on the angle at which sunlight strikes its dust and gas. When viewed from behind, the tail may appear brighter and longer, reflecting sunlight forward like a veil illuminated from the back. From the side, layered gradients become visible soft transitions, from bright center to diffused edges. When seen head-on, the coma may glow like a round, delicate lantern floating in space. Each perspective reveals a new facet of the comet's gentle beauty, proving that even a single object can hold countless ways to be seen quietly and peacefully. Sometimes, a comet's dust contains rare organic compounds that fluoresce under ultraviolet light. These compounds release a faint glow when excited by sunlight, adding subtle shades to the coma. The glow is extremely gentle, not enough to shine brightly, but enough to add a dreamy softness to the comet's appearance. This faint fluorescence is unique, a whisper from molecules that have remained unchanged since the dawn of the solar system. When they finally encounter sunlight, they reveal their presence through the softest radiance imaginable. The rotation of a comet often creates faint spirals in the flow of dust leaving its surface. These spirals emerge when jets of vapor released from different regions align with the spin of the nucleus, wrapping the dust into curved, graceful shapes. The resulting structures are barely visible, like delicate fingerprints imprinted into the coma. They drift outwards slowly, unraveling over millions of miles. These gentle spirals give the comet a quiet sense of motion, even when observed from far away, as if the nucleus is weaving soft patterns into the space around it. Even after a comet finishes its journey near the Sun, the effects of its passage continue to echo for years. Dust and gas left behind fill the comet's orbital trail, creating regions of space that glimmer faintly when touched by sunlight. These trails become the sources of meteor showers, drifting steadily across Earth's path. The comet may be far away, asleep in the darkness once more, but the remnants of its activity continue to create gentle light in Earth's sky, small, brief streaks that last only a heartbeat but carry centuries of cosmic history. It's a reminder that even the quietest wanderers leave behind beauty long after they have passed. As a comet approaches the Sun on a long returning orbit, it moves through regions of space it has not visited for thousands of years. Along the way, it encounters subtle changes, new streams of dust from other comets, faint gravitational influences from wandering asteroids, and solar wind patterns that have shifted since its last passage. These interactions are gentle small adjustments that accumulate over ages. By the time the comet nears the inner planets, it has been shaped quietly by countless invisible hands. Its brightness, its coma, and its tail are all the results of these tender cosmic influences, working patiently across millennia. Some comets release dust in pulses that match their slow rotations. As they turn, one illuminated region warms enough to sublimate, releasing a soft cloud of particles. When that region rotates into shadow, the outgassing pauses. Over many rotations, this process creates faint rings or shells of dust that drift outward from the nucleus in layered waves. These waves are so subtle they're often invisible from Earth, but spacecraft have captured glimpses of them, thin, translucent shells expanding like ripples on a perfectly still pond. These structures reveal the comet's heartbeat, a gentle rhythm shaped by sunlight and spin. The color of a comet's glow depends on the gases it releases. Cyanide creates soft turquoise, carbon dust produces muted grays, and water vapor scatters light into pale white. When all these emissions mix, The coma takes on a dreamy, pearlescent quality, a blend of hues that shift as the comet rotates. None of the colours are harsh. They resemble watercolour washes, spreading softly into one another. This pastel glow makes each comet unique, a drifting lantern shaped by its own chemistry and temperature. Some comets leave behind particles that slowly spiral toward the sun over decades or centuries. These particles join the interplanetary dust cloud that fills the solar system with faint, diffuse light. As sunlight scatters through this dust, it creates a gentle haze that can be seen from dark locations on Earth, a dim, triangular glow known as the zodiacal band. This quiet illumination is a collective gift from countless comets, each one contributing grains of light that drift inward, fading into the slow radiance of the inner solar system. Even after they are gone, comets continue to soften the night. There are comets whose paths bring them extremely close to the sun, so close that they appear to skim its surface from our point of view. These are called sun grazers. Their journeys are daring but not reckless. They follow precise orbits guided by gravity. As they approach the sun, intense warmth causes rapid sublimation, producing massive but gentle halos of vapor. Some sun grazers do not survive. Their nuclei soften and dissolve into streams of dust, but even their dissolution is quiet, more like a slow unweaving than a destruction. They leave behind sparkling trails that drift outward, carried by the solar wind like strands of stardust. A comet's shadow cast by the nucleus across its own coma is one of the most delicate shadows in the solar system. It is almost invisible, a barely perceptible dimming within the glowing cloud. The shadow forms because the nucleus blocks a small portion of sunlight, creating a soft pocket of darkness behind it. This tiny dimming shifts as the comet rotates, moving gently through the coma. It is a quiet reminder that even glowing bodies have moments of darkness, and even shadows can exist peacefully within light. Comets sometimes interact with planetary atmospheres from afar. When a comet passes near a planet, dust released into space may drift into the planet's upper atmosphere over time. Here it burns gently, leaving faint chemical signatures that reveal information about the comet's composition. These interactions happen slowly, unnoticeably, without ever endangering the planet. It is a form of cosmic storytelling, the planet reading dust left behind by a wandering visitor, learning about distant regions of the solar system from particles that drift down like soft messages. Occasionally, comets pass through regions filled with faint electromagnetic fields created by the sun or the giant planets. These fields guide ions in the comet's tail into graceful curves and smooth arcs. The resulting shapes are ephemeral structures that last only moments before dissolving back into flowing streams of plasma. These curves resemble the slow movement of silk underwater, gently bending and reforming as invisible forces shift. They are some of the most tranquil expressions of physics in motion, visible only because comets reveal them through light. Some comets become part of human culture, appearing in artwork, myths, and ancient records that span continents. Though early observers could not explain their nature, they recognized their gentle beauty and temporary presence. Comets were seen as lanterns, messengers, wandering spirits, or symbols of renewal. Across centuries, they became part of humanity's collective dreamscape quiet, graceful visitors whose rare arrivals reminded people to look upward and notice the stillness of the night sky. Even today, a bright comet inspires the same timeless wonder. When a comet completes its journey near the sun and begins drifting back toward the darkness, it leaves behind no footprints, no sound, no evidence of its passage except the dust trails that will eventually fade. It returns to the silence from which it came, the cold outer regions where time moves slowly and light is scarce. There it rests, unchanged at its core, waiting for the next gentle tug of gravity that will call it inward again. Its life is a cycle of sleeping and glowing, fading and returning, always patient, always serene. In its quiet journey, a comet reminds us that beauty can be ancient, motion can be gentle, and even the smallest traveler can carry the calmness of the cosmos within its light. As our long, quiet journey with these ancient wanderers comes to an end, let your mind drift for a moment in the gentle afterglow of their stories. Comets have carried us across vast distances tonight, from the cold silence of the outer solar system to the warm embrace of the sun, and back again into the deep, patient darkness where these travelers rest. Their paths are long, their rhythms slow, and everything about them moves with a softness that feels almost like a lullaby written into the fabric of space. These drifting bodies made of ice, dust, and memories older than the Earth have shown us a universe that does not rush. They glow when the sun touches them, they fade when the darkness returns, and they move through space guided by forces too gentle to hear, yet too ancient to ignore. Even in their brightest moments, they shimmer quietly. Even in their transformations, they remain calm. A comet's entire life is a lesson in unhurried existence, a reminder that beauty can take its time. If you close your eyes now, you might still sense the long, luminous tails stretching behind them, drifting like silk across the night. You might feel the silence of their frozen hearts, the chill of the outer reaches where stars shine faintly, or the soft warmth of the sun brushing against their surfaces for the first time in thousands of years. You might sense the way they exhale dust into light, how their comas bloom like delicate lanterns, and how their orbits curve gracefully through the solar system like the strokes of a gentle artist. As you settle deeper into rest, imagine one of these wanderers gliding through the dark, quiet, steady, unbothered. Imagine its slow arc, its centuries of stillness, its brief moments of glow. Let that rhythm guide your breath. Let its calmness become yours. Thank you for spending this night with the sleepy scientist. If this peaceful journey helped soften your thoughts or brought you closer to sleep, you're welcome to return any time. There is always more quiet beauty to explore, more gentle science, more cosmic calm, more nights where the universe whispers in a language made of light. May your dreams be slow, your thoughts gentle, and your sleep as deep as the darkness where comets rest. Good night.